All right, welcome to this explainer, where we're basically playing detective. We're digging into a pretty cool, almost magical idea. What if you could take all that greasy leftover oil from restaurants and turn it into fuel? Sounds great, right? But does the story actually check out? Well, we're going to follow the carbon trail and find out what its real climate impact is.
I mean, that's really the big question, isn't it? Can yesterday's fried food really power tomorrow's trucks? You know, on the surface, taking waste and turning it into energy, it sounds like a perfect win-win. But to get the real answer, we've got to look past the hype, past the sales pitch, and just follow the evidence. And that means we're tracking every single gram of carbon, all the way from the deep fryer to the fuel tank.
And to make this totally real, we're not just talking in hypotheticals. Nope, we are zeroing in on a specific, real-world factory in Egypt. This place cranks out 2,400 tons of this biodiesel every single year from restaurant waste. So this is our case study. It's where we get our data, and it's the absolute center of our whole investigation.
Okay, so like any good investigation, first thing you got to do is draw the crime scene tape, right? You need clear boundaries. We can't just, stick a sensor on a truck's exhaust pipe and call it a day. That's not the full picture. To get the true carbon footprint, we need to map out the entire process, from the second that old oil gets picked up all the way to the moment it's actually burned as fuel.
And we actually have a rule book for this. It's called a life cycle assessment, or LCA for short. And you can really think of it as the official detective's manual for this kind of carbon accounting. It's a serious international standard, ISO 14067 to be exact, and it tells us precisely what to measure and how to measure it. This is what makes sure our results are legit, accurate, and totally credible.
So this investigation, it covers the entire life cycle of the fuel, what scientists call cradle to grave. So the cradle, that's step one, collecting all that used oil and actually producing the fuel. Then after it's distributed, we get to the grave, which is just the moment the fuel is burned up in an engine. Every single one of these steps leaves behind a carbon fingerprint. And yeah, we're tracking every last one.
Okay, so let's look at the evidence list, the key ingredients. To make just 1 ton of this biodiesel, the factory needs, get this, over a ton of used cooking oil. But it's not just oil. They mix in chemical ingredients like methanol and a catalyst. Plus, the whole process needs a good bit of electricity and heat to run. Now, each of these things is like a clue, right? It's a hidden carbon cost that we absolutely have to account for. Take methanol, for example. That stuff is usually made from natural gas, so it has its own carbon footprint from its production, long before it even gets to the biodiesel factory.
So now that we've gathered all our evidence, it is time to start following that carbon trail. We're going to dig into the data and identify our main suspects. The parts of the process that are kicking out the most emissions.
The whole thing kicks off with a kind of a broad look. It's called a screening assessment. Basically, the investigators use existing data to build the first draft, a preliminary model. Now, this first pass isn't going to give us the final answer, but it's super important because it points us toward the hot spots, the parts of the process that are probably responsible for the biggest slice of the emissions pie. And what do you know? This initial assessment points to 2 main suspects right off the bat. First, the energy needed to actually run the factory. That's a huge 45% of the estimated footprint. And second, making that methanol we talked about, that's another 28%. Boom. These are our hotspots. This is where our investigation really needs to focus.
Okay, and this is where the investigation gets really serious. The team doesn't just stick with those estimates, no way. They go right to the source, to the factory in Egypt, and they collect what's called primary data. They're measuring the exact amount of electricity being pulled from the local grid. They're tracking the actual fuel used by the trucks collecting the oil. This is how you turn a rough guess into hard, solid, verifiable evidence.
All right, the field work is done, the lab work is complete. All the evidence has been analyzed, the numbers have been checked and double-checked and triple-checked. It's time. Let's reveal the final, verified carbon footprint of this whole waste-to-fuel process.
And here it is, the final number. For every single liter of this biodiesel from Egypt that's produced and then used, the total hit is 1.85 kilograms of CO2 equivalent emissions. That is the total, all-in, cradle-to-grave carbon cost. That's the number.
So how does that number break down? Well, this chart right here confirms our initial suspicions. The biggest culprit, by far, is the energy used to make this stuff. And right behind that, the emissions from making the methanol. See? That initial screening pointed us in exactly the right direction, and now the detailed, real-world data has confirmed our main culprits.
Okay, so we have our number, 1.85. But, a number all by itself is pretty meaningless. Is that good? Is it bad? Who knows? To really close this case, we have to compare it to something. We need to see how it stacks up against the alternative, the fossil fuel that this biodiesel is supposed to replace.
And here we go. It's the showdown. On one side, we have our usual suspect, conventional fossil diesel. Its carbon footprint? A hefty 5.6 kilograms per liter. And on the other side, our biodiesel, coming in at just 1.85. Wow, the difference is, well, it's stark. It's not even close.
But this is the number that really matters. When you do the math, making the switch from regular old fossil diesel to this biodiesel made from cooking oil, it adds up to a 67% reduction in carbon emissions. 67%.
So the big takeaway, the crucial point, is this. The verdict is in, and it's a huge win. By taking something we just throw away, restaurant waste, and turning it into fuel, this process in Egypt is slashing the carbon footprint by more than 2/3. Our investigation proves there's a massive climate benefit here. Case closed. So we've just seen the case for used cooking oil, and it's pretty compelling. And it really makes you wonder, doesn't it? What other stuff that we're throwing away right now is just sitting there, waiting to be turned from a problem into a solution? What else could be out there ready to power our future?